Aging disk. To understand the aging disk, you must understand the normal intervertebral disk. We know the disk has an annulus fibrosus outside and nucleus bulbosus inside. With aging, there is degeneration of the disk that will alter the function of that disk. What is the function of the intervertebral disc? It links the vertebral bodies together, and it is responsible for about 25% of the spinal column height. It is a cushion between the vertebrae, so it allows spinal motion, but also provides stability. The normal intervertebral disc is made of two components. The annulus fibrosus, which is the outside part, and the nucleus pulposus is the inside part. The annulus fibrosus has a high collagen and low GAG concentration, which is low glucosaminoglycan. Collagen will give the tensile strength. The collagen in the annulus fibrosus is type 1, the same collagen that's present in the bone. So the annulus fibrosus is a hard outside structure that protects the nucleus pulposus. So that annulus fibrosus is the outer structure that surrounds or encases the nucleus bulbosus. It has a multi-layer laminar architecture made of type 1 collagen. Each successive layer is oriented at 30 degrees to the horizontal in the opposite direction, leading to crisscross type pattern. This composition allows the annulus, which has the highest tensile modulus, to resist the torsional, the axial, and the tensile loads. The inner part of the annulus has fibrocartilaginous tissue that gradually blends with the nucleus bulbosus, and posterolaterally, the annulus is thinner and has a disorganized collagen and has greater proportion of vertical fibers. It is the weakest part of the annulus, and this area contributes to the majority of disc herniations. How about the nucleus bulbosus? It is the central part of the intervertebral disc. This is the part that's surrounded and protected by the annulus fibrosus. It has type 2 collagen, also has proteoglycans, and has large percentage of water. The nucleus pulposus is high in GAG and low in collagen, and because it's low in collagen, it's not a hard structure, it's a soft structure, and is good in compression. So the nucleus pulposus allows compressibility, allows load to be placed on the spine. And the collagen type is type 2, which is the same collagen that is present in cartilage. So it is not a tough collagen, it's gentler, softer collagen. The annulus fibrosus has a high collagen and low proteoglycan ratio. The nucleus pulposus has type 2 collagen and also has a lot of proteoglycan and has a high percentage of water. The hydrophilic nature of the proteoglycan will be responsible for the height of the intervertebral disc. The molecule of the proteoglycan is responsible for the hydrophilic behavior of the nucleus pulposus, and it contributes to most of its ability to maintain the hydrostatic pressure. The proteoglycan constitutes a low percentage of dry weight within the annulus and a high percentage of dry weight within the nucleus, and it interacts with water to resist compression. Aggrecan is the most abundant proteoglycan within the intervertebral disc. It's a hydrophilic molecule which attracts and maintains water within the disc, and that will help to maintain the compressive strength of the disc. Proteoglycan can be large proteoglycan, such as the aggrecan, or it can be small proteoglycan, like dicorin and biglycan. The nucleus had the highest concentration of aggrecan and water and lower collagen content. It's type 2 collagen. You don't need collagen there. You don't need strength, but you need strength in the outside layer. So within the functional spine unit, the nucleus pulposus function is to resist compressive loads. We should know that pressure within the nucleus pulposus of an adult intervertebral disc is greatest when sitting unopposed. The lowest is when lying supine. The nucleus pulposus is elastic, so it has a low collagen and high proteoglycan ratio. And it also has chondrocyte-like cells that is responsible for producing type 2 collagen and proteoglycans. So we have to connect these cells to nutrition or blood supply. So what is the blood supply of the disc? The intervertebral disc is an avascular structure in adult. The capillaries will terminate in the end plate. The nucleus pulposus receives the majority of its nutrition from diffusion from the blood vessels within the end plates. The annulus is not porous enough to allow diffusion of the fluids. The nutrients will come from the blood vessels at the margins of the disc, and it has to go through the cartilaginous end plate to reach the disc cells. The blood supply to the end plate and the outer annulus decreases with age, and the cellular metabolism is affected with decreased nutrition. With aging, there will be intervertebral disc degeneration and will be decreased nutrition to the intervertebral disc due to decreased vascularity. The nucleus pulposus of the intervertebral disc has chondrocyte-like cells that have a limited blood supply, and it generates energy through an anaerobic glycolysis. The nucleus pulposus needs glucose because they obtain their energy through glycolysis, even in the absence of oxygen. The disc cells does not need oxygen to remain alive, but they need glucose, so they die at a low glucose level or acidic pH. Thank you very much. I hope that was helpful.